I will be introducing our group members. In the middle is our group leader, Nur Najiha Quratul Ain binti Muhammad Hairul Azmir. Then on the left are Duratun Nasiha Naqiyah binti Muad Nur and Atifah Yasmin binti Muad Huzairil Nizam. Then on the right, we have Shahira binti Abdul Razak and Nik Humaira Maisara binti Nik Zul Rusti.
Assalamualaikum. Today we will be presenting our mathematical assignment on modeling population growth using first order differential equation. For this particular assignment, we have chosen population of Singapore because the growth pattern is increasing exponentially over the years. Hence, it's suitable to apply the first order differential equation. In this slide, this table shows that the population of Singapore from the year 1990 until 2010.
Assalamualaikum. My name is Shaira and I will be continuing our discussion by informing you of the steps to apply first order differential to find the general solution for the population of Singapore. Before we start, we must understand that the population growth of Singapore is proportional to the population. From here, we could define the growth rate dP over dt to be equal to the product of k and p, where the function pt is the total population at time t and k is a constant probability. First, we solve the equation using separable variables by separating variable p and t. We will get 1 over p dp equals to k dt. Then we integrate both sides of the equation and get ln p equals to kt plus c. Next, to remove the logarithm, we exponentiate both sides and get p equals to plus minus e to the power of c times to e to the power of kt. The general solution can then be simplified to p equals to a times e to the power of kt, where plus minus e to the power of c is a. Using the initial condition, t equals to 0 for the year 1990, the total population equals to 3047,132, we can conclude that A equals to the total population at year 1990, which is 3047,132. Thus, the general solution becomes P equals to 3047,132 times e to the power of kt. Next, we counted the value of constant k by using t equals to 1 or at year 1991 where p is equal to 3135083. By inserting this into the general solution we arrived at earlier, we will find that k is equivalent to 0.0285. Hence, the particular solution is now p equals to 3047,132 times e to the power of 0.0825 t. Now, by using the general solution we arrived at, we can calculate the estimated past or future total population in Singapore. To predict a future record of population in Singapore, we set t as 23 when the year is 2013, which we then calculate and found the estimated total population in 2013 to be 5369097. Then, to predict a past record of population in Singapore, we set t as -7 when the year is 1983, which amounts to the estimated total population in Singapore in year 1983 to be 2496028. Finally, to find the percentage error of the visualized graph, the difference of the actual total population and the estimated total population is divided by the actual total population all in the same year times 100%. Hence, the percentage for our general solution amounts to 0.56%.
Next, for the discussion part, the calculated value might be different from the actual one due to human unpredictability behavior such as sudden death and sudden birth. The percentage error for the past is 0.56%. The difference from the actual value and the calculated value that come from the scattered pattern of migration, plus they can be delayed in registering birth, death, and migration. So it can affect the accuracy of the real-time population in Singapore. Back then, the population in Singapore changes mainly due to this factor: birth rate, immigration, and healthcare factor. In mid-80s, increasing birth rate had been recorded in Singapore that contributed to significant growth due to pro-natalist policies. Other than that, to support economic growth, Singapore allowed more foreign workers and professionals to enter the country as a result of the government's proactive initiatives through liberal immigration. The past decade has seen a rapid growth in the foreign permanent resident population, who represent fastest growing segment in Singapore. Besides that, healthcare in Singapore got better, resulting babies can get healthier and people can live longer. Future population in Singapore are expected to increasing. There are factors that can affect the future of Singapore's population. Firstly, significant rise in immigration which increasing foreign workers and professionals and also permanent residents contributed to significant growth of population. Other than that, advanced technology in healthcare can lower mortality and extend life expectancy. This will result in increasing elderly people and lower death rate.
For our assigned task, we have been given a question to use Simpson rule to find the integral of fx from x equals to 11 over 2 to x equals to 13. For the 5 and 7 ordinate, which is n equals to 4, and here is n equals to 6. And then we have to give our final answer correct to 5 decimal places. Before that, we can use this formula to find the integral of 4 and 6 subinterval as it describes the form of approximation of Simpson law. But for this task, we focus on solving the problem using Excel. So this is the tabulation for n equals to 4. That is calculated by using Excel worksheet. Firstly, we use this formula, which is h equals to b minus a over n, where our b is 13, our a is 11 over 2, which is 5.5, and our n is equals to 4. And then we substitute the value into the given equation, and then we get the value of our h is equals to 1.875. And then next step is to find the value of x from the value of h that we calculated earlier. So you just add on the formula and then you will get the rest of your x. Next, to find the value of fx, we substitute the value of x that we calculated earlier into the following equation that are given from the question, and then we will get the rest of the fx. Next, we multiply the coefficient with the values of fx that we calculated earlier, and then this is the calculation to find one of the values. So I just pull it down and then I'll get the rest of the value. To find the sum of multiplication values we find earlier, add on all the values as follow. We use this equation to get the sum value, and then we will get this value. And lastly, we find the integral of 4 subinterval as follow using the Simpson approximation just now, this. And then by using decimals, we can see our graph is like this. And then as you can see, the given value here is here, and our actual value is here. And then we calculated the percentage error using this formula, and then we get this value.
Okay, so moving on to 7 ordinates. Okay, here's our table. We haven't completed them yet. This is the A, the B, the lower and upper limits. This is the C, the sub-intervals. Okay, now H here, if we were to observe it, it is lower than the other H in the 5th ordinate. Sorry. Okay. Okay. So now the X here, it starts with 5.5. Now it's not supposed to be 5.5. Have to edit it. It's not. Okay, now we can just drag it here. Should just be able to drag it, sorry. Coming outside. Okay, now the fx, we have used this function, the formula. Okay, and then we just drag it down. Alright, now this is the answer it gives us. It should be the actual value of the area below the graph. That's it. Next, moving on, so we have completed our Excel. Now we can compute our graph. So using Desmos, we can put in the A values, B values, and N values. So the app automatically gives us the area below the graph, which is 47.555884418. Okay. So moving on to percentage error, after we done the Excel, we got the actual value of the we got the estimated value of the graph, and then we did the graph using Desmos. We already obtained the actual value, and now we can calculate the percentage error. Okay, so using this formula, we can put in our values and then get this percentage, which is pretty low. That's all. Thank you.